schooling decision by optimal stopping. What the optimal stopping means, it's something like this. You start the schooling, okay, and then every moment, every year, basically what you're thinking is whether I should stop or go on studying. Okay? So the rule says that once the marginal rate of return to education equalizes the discount rate, then that's the point where you stop. Okay? That's what we call by optimal stopping rule. So optimal stopping rule actually happens in many cases in economics. For example, very simple optimal stopping rule is something like if you, let's say, raise a tree, okay, to sell, okay, then obviously there is a benefit from the raising the tree bigger and bigger, but there is a cost of raising it. So there must be optimal timing to stop growing your trees and sell it, right? So that's the simple, example of optimal stopping. So, and then education is, in a way, it's simple. I mean, it's similar, okay? It's like your tree. So you are accumulating your human capital through education, but you cannot do it forever, okay? At some point, the cost will exceed the benefit. So you should find a timing of stopping it. And this rule basically tells you when to stop. And if you look at this diagram, I think you can point out that there are two reasons why individuals have different education level. One is obviously that if the individual has different discount rate. The another reason must be what? The other reason must be MRR must be different. Okay, there are only two things that exist in this diagram: it's R or MRR. So the individual's education levels differ because R is different or MRR is different, probably because both are different. Okay, but we will look at one by one. So in this diagram, we look at the case where that MRR is identical, but R is different. Okay? So with the same MRR, with different discount rate, higher discount rate, this individual will stop early. Okay? So at 12 years of education, and this Bo, the second individual, will stop at 16 years of education with lower discount rate. Okay? And from this information, what you can do is that we can actually recover the wage schooling locus. How? First thing, what we know is that since these two individuals have the same MRR, it means that their wage schooling locus must be identical. So what they are choosing is the only two different points in the same wage schooling locus. So how do we know that the point? First thing is that there is this number of years and the money they make, okay, the income they make. So we know their years of schooling, 12 years for R, okay? And we know how much they actually make because R chose 12 years, so we can get the data of his income from, you can ask him, basically. So that is WHS, which is R's pay. And we can say that this WHS is actually this point at this wage schooling locus. Okay? And then for Bo, we can have the same thing, 16 years, and then Bo's income, which is W call, then we have these 2 points. Okay? So what we know here is that if R had different discount rate, let's say if R had the discount rate as low as Bo, and then the R who would study for 16 years, and his income would be W call, because he's just moving from this point to this point on the same wage schooling locus. So you can say that, by having 4 more years of education, R would receive would get the salary of W call. And so for the same thing, for Bo, if he had stopped at 12 years, for whatever reason, he would get WHS. Okay? So we can say that on the same wage schooling locus, if we have an individual who study for 12 years, we know that WHS is his income, and 16 years W call. So we can actually calculate, okay, by having 4 more years, by how much this individual's income would increase for R's case, for example. So if there is a, for example, if there is a, let's say, policy, okay, some type of policy that, let's say, make R to go to school for 4 more years. We just force him in a way. Or we can give him an incentive by giving him, let's say, scholarship. Okay. So if he has, let's say, lower cost of education, then even with high discount rate, he would have gone to 16 years of education. Then we know exactly how much his income would increase. So from the policymaker's point of view, that's very useful information because we know that for some reason, let's say we can increase individual's education level by, let's say, 4 years using that kind of scholarships or money, then we know exactly by how much this individual's income would increase. So we can make this information to make decisions on education investment. Okay? So that since this difference gives us basically a difference in the human capital level, and then how the human capital level is affects how the human capital level is appreciated in the labor market. Okay, so using that, let's say it's a 10% increase. Actually, it's much more than 10% increase. Should be. So let's say if it's a 40% increase from WH's W call, then you make 4 more years of education. Let's say per year, let's say 10% increase in the income. Okay, then it could mean that it's very useful investment. So you can, you can make education investment nationally. Okay, so that is the case where the discount rate is different. But there is a second case. The second case is their MRR is different. Okay. So let's assume that their discount rate is same, okay, but MRR is different. Okay? So there is a MRR for Ace and MRR for Bob. Okay, what you see here is that MRR for Bob is higher than MRR for Ace. Okay? Which means that for the same years of education, Bob makes more, okay, out of that education than Ace. So then we economists say that Bob has higher ability than Ace. Okay? So in a sense, it's an ability to convert your education into your income. Okay? So Bob has higher ability than Ace. With the 2 different MRR line, even with the same discount rate, we can easily see that the education levels will be different. The individuals with higher MRR will make more education investment. Okay? Simply because the rate of return is higher. Okay? So they will make more investment. And in this case, Ace will study for 12 years, Bob will study for 16 years. Okay? Get that? Now, let's think of their wage schooling locus in this case. Since their MRRs are different, that should mean that Ace's wage schooling locus must be different from Bob's wage schooling locus. Okay? More specifically, Ace's wage schooling locus must be flatter than Bob's wage schooling locus. Okay? So it increases for Ace, but it much more slowly than Bob. So overall, the Bob's wage schooling locus must be above the Ace's wage schooling locus. And Ace and Bob each chose 1 point, okay, at their own wage schooling locus. So Ace chose this point, and Bob chose this point. Okay, got that? Now, the thing is, we don't actually see the Ace's wage schooling locus, the whole thing. We see only the 1 point. And for Bob, we see only 1 point. Now, how can we recover wage schooling locus for these 2 individuals from these 2 points? Is it possible? It's not possible, obviously. Okay. The only thing we can do is probably to just connect PAs and PBOB. Okay, so we have line Z. Okay. If Ace and Bob was this case, two different discount rate, but the same wage schooling locus, then we would say that this shows the wage schooling locus for these two individuals. But that's not the case. In this case, actually, these are just two different wage schooling locus and just two different points. Okay? And when we connect them, and if we misinterpret it as the wage schooling locus apply to both individuals, then we make a serious mistake. How? Okay, the idea here, it's the same idea as the previous case. If we force Ace to go to school for 4 more years, giving a scholarship or something, okay, then it is likely that if we give Ace the scholarship so the Ace can go for school for 4 more years, then we would expect his income would be W-call, right, instead of WHS. Okay? However, in this case, Ace's income would not be W-call. It's going to be W-Ace, much lower. Why? Simply because Ace's wage schooling locus is flatter and it's located at a lower positions than Bob's wage schooling locus. So because of the ability difference, okay, Ace cannot reach the level of W-call. Ace will reach, let's say, only W-Ace. Okay. But the thing is, unless Ace is born twice and repeats education, 1 year, 1 life, 12 years. Another life, 16 years. And we observe their both lives. Unless we do that, we will never see these 2 points. Okay? In 1 life, 1 education only. Right? So the thing is that we will never see actually these two graphs if their abilities are different. Okay? But the thing is that so if we knew that only their discount rate was different, then its wage schooling locus is going to look like this. If you only knew that their discount rate was same, but only the wage schooling locus is different, then we would say that okay, the Ace will never reach that point. But the thing is, the unfortunate thing is that actually we don't know, right? We don't see each individual's discount rate. It's not written, right? It's not written in your face. We never know. We would never know their discount rate. We would never see their ability level. Okay? So the 2 things are just unknown. So we have to make a guess, and usually the guess, it's very difficult to say that whether the guesses are correct or not. Right? So the thing is, at the end, we are not sure what makes their education level different. Okay? It could be discount rate. It could be ability. Okay? Or it may be both, probably both, okay? But we don't know which one is more important. So in the end, actually, we are not sure about by how much an individual's income would change if we change the individual's education. Okay? But one thing we know from this diagram is if abilities are actually different, and if we use this line Z as the wage schooling locus for Ace, okay, that is obviously overstating MRR for Ace. Okay? What we know is that the real MRR for Ace must be smaller than the slope of this line. Okay? That's one thing we know. Okay? So the logic goes, so if we pick an individual who had only high school education, okay, in the real data, let's say, and if we pick individuals from those who have college education, okay, their discount rate may be different. But at the same time, it's likely their abilities are different. Okay? So let's say we see the educational income of high school educated people and income of college educated people. Then we can say that, let's say their difference is, let's say, 40%. Okay? Then what it says is that if we somehow force the individual who have only high school education, if we force that individual to finish college, then their income will go up likely, but not as much as 40%. Why? Because the individual who chose to have college education are likely to have higher ability. Okay? So what we see, the 40% is actually this line. Okay? Not this line or this line. Okay? And as you can see that this line is much steeper, okay, than this line or this line. Okay? It's even steeper for Bob's case. Okay? So we have a special name for this. The special name is called ability bias. Okay? So ability bias basically means that if individuals differ in abilities, the observed earnings difference means that the data that we actually have. Okay? The observed earnings differential by education, which is actually line Z, overstates. Okay? It exaggerates, overstates the true rate of return to education for a given individual. So true rate of return to education must be lower than the observed rate of return to education if individuals differ in abilities and that abilities affects individual's choice of education level. Okay? And which is likely, so we have this special name, the ability bias. So actually in the labor economics research, there has been lots of studies to find out how big this ability bias is. Okay? Because, you know, I just said about the policymakers' problem. So policymakers' problem is to find whether this education investment is worthwhile. They look at 40%, let's say, 10% per year. But what the theory says, that 10% per year is not the true rate of return. If you force somebody to go to college who would have stopped at high school, this individual income would go up, but what it says is that it's not as much as 10% per year. It must be lower. Then how low, right? We actually don't know yet how low it is. Is it like 5%? Or is it like 2% or 8%, right? So 8% is still a pretty good number, but if it's actually 2%, then probably it's not worth to, let's say, build more universities and give funds to high school graduates to go to school. Probably 2% is too low, right? So it's obviously it's very important question from public policy point of view how big this ability bias is. Okay, we see observed difference. Then if we knew the ability bias, then we would make very good decisions. But so there has been a lot of study about ability bias. Okay, it's very difficult to get this number down. Why? Because, as I said, there are too many things unknowable. We don't know their ability, actual level of ability, right? We don't know their discount rate. So there are too many unknowables. So it's very difficult to get that information out of the data. Okay? So there has been lots of debates about it. So one way of, one kind of study that studied ability bias is, for example, to use data from identical twins. So identical twins, they have the same gene, same DNA. So they have basically their fundamental biological makeups are identical because they just from the same gene, right? So they use they look at the identical twins' education level and their incomes, right? So if their abilities are exactly the same, right? Then what we have is, you know, then we can say that their education level difference is only from discount rate, because their abilities are same, so their wages equivalent low cost must be same. So their wage level, education level is different. Then it must be discount rate. Then we get the same first case. Okay? So and then there has been studies. Then the studies show that actually their observed rate of return to education is actually smaller than the observed return to education for general public. So there must be some ability bias. Well, it turns out that the studies usually show that ability bias is not as big as we think. Okay. So even without ability bias, I think ability bias is not that big portion. But at the end, actually, we are not very sure. Okay. It's just the indication is the ability bias is not likely to be small, is not likely to be large, but we don't actually see ability. So there must be, if the research was wrong, then we probably get the wrong number. But what we hear is that ability bias is likely to exist. Okay. So far we have looked at two cases. Now, there is one more complication. Okay. This one more complication makes things really, really complicated. Okay, now, here, think of two individuals, Willie and Wendy. Okay, this Willie and Wendy, two different individuals, and they have two different comparative advantages. Meaning is that they have Willie and Wendy. Okay, let's say there are two kinds of jobs in this world: blue collar job and white collar job. Okay, blue collar job does not require any college education. White collar job requires college education. Okay, and Willie and Wendy. Okay, but they have different. What do you say? Different propensities. It's not, we don't call it ability, different capacity. Okay, let's call it capacity. Okay, they have two different capacities. Okay, so in this case, Willie is actually, relatively compared to Wendy, is pretty good at blue collar job. Okay, so Willie is very good at with hands, let's say. Okay, so he can do lots of things with his hands. So blue collar job just suits him. Okay, if Willie had college education, Willie would earn more. Okay, even Willie had blue collar job, very good capacity for blue collar job. Willie would earn $40,000. Okay, with white collar job. Now Wendy is pretty bad at blue collar job. Okay, and good at white collar job. Okay, so if Wendy had only blue collar job, she would earn $15,000. But if she had white collar job, she would earn $41,000. Okay, get that? So it is quite, it is not bad assumption to think that these individuals have different capacities. Okay. So some people are pretty good at something, and some there are people who are very good at using hands. Like they make great carpenters, great craftsmen. Okay, people who are pretty bad at hands, like me, like myself. Okay, would make a very poor living. Okay, as a carpenter or something like that. Okay, so I'm like Wendy. Okay, and these two people know exactly. Okay, their prospective income. So Willie knows that I would make $20,000 in blue collar job, $40,000 in white collar job. Wendy, $15,000 in blue collar job, $41,000 in white collar job. Okay. So they will make choices. Willie will choose Willie will decide whether to have a blue collar or white collar. Okay, Wendy also. So what's each person's choice? Okay, what we assume here is that there are two periods, okay, and discount rate for each person is 10%. Okay, and you can be a blue collar job. You can have blue collar job right away for both periods. Okay, but if you want to have a white collar job, in the first period, you should study. So you earn nothing. In the second period only, you will get the white collar salary. So for Willie's choice, for Willie's blue collar job, the discounted lifetime income is $20,000 this period plus $20,000 next period, but it should be discounted because it's in the next period. So 1.1, which is 38,182. Okay? And for white collar job, the same thing for Willie, but $0 this period. So $40,000 in the next period. 40,000 divided by 1.1, so 36,4. So what is the Willie's choice? Willie will choose blue collar job. Okay. How about Wendy? We do the same calculation. For Wendy, for blue collar job, 28,636. And for white collar job, it's 37,273. So which is Wendy's choice? Wendy will get white collar job. Okay. So here in the actual data, we don't see both numbers. Okay. What you see is only one number. What you see is the Willie gets the blue collar job, earns $20,000. We never know that Willie would earn $40,000 with the white collar job. Wendy, we see Wendy is having a university education, white collar job, $41,000. Okay? We would never know that Wendy would earn $15,000 without the college education. Okay? So what we see is only these 2 points. Okay? It's like the same thing, like ability bias. But the bias comes here is for different reasons. It's not the ability. Okay? In the ability bias, okay, there is no comparative advantage in occupation. Okay? The good ability person earns always more with the same level of education. Okay? In this case, it's different. Okay? Actually, if they had blue collar job, Wendy would earn less than Willie. With a white collar job, actually, Willie would earn less than Wendy. Okay, so their positions are different. It's like their wage schooling locus cross each other, right? Okay, so this is another case. This is not the ability bias. Ability bias basically means this. Okay, but this is a crossing case. Okay. So then what we see here is that what's funny is something like this, right? We will have these 2 points. This is what is it? This is Willie. Okay, this is Wendy. Okay, then we have these 2 points. So similarly, we can just connect these 2 points to make observed wage schooling locus. Okay. And this wage schooling locus, as you can see, is this one is flatter than Wendy's wage schooling locus. Okay. But steeper than Willie's wage schooling locus. Okay. In the ability bias case, the observed wage schooling locus is steeper than both wage schooling locus. In this case, this is steeper than Willie's wage schooling locus, but flatter than Wendy's wage schooling locus. Okay. So, at the end, okay, what it says is basically it's very difficult to find the actual marginal rate of return to education for each individual. Okay, we talked about ability bias. So ability bias seems to make us into a difficult situation. But there is one positive thing, because what we can say is that this is the maximum. Right? The actual marginal rate of return to education should be lower than observed rate of return to education. That's the ability bias. So there is one positive thing. But in this case, there is no such thing as positive thing. Okay? What it says is that, okay, this wage schooling locus must, observed rate of return to education must be too high for those work with only high school degree, but this is too low only for those who work with the university degree. Okay, so it must be in between. Okay, so we have all sorts of different arguments. Okay. So what you can say is basically that by comparing the earnings of different workers, okay, we cannot say whether the workers choose to maximize their lifetime earnings. Whether actually the idea of human capital investment model is that individuals choose their education level to maximize their lifetime earnings. Okay, then whether we can actually test it using the data, but it says no, because it's different individuals. They are all in different points in the different wage schooling locus. So we cannot even see whether they are maximizing their lifetime income. Okay. One person may say that really it's stupid, right? Wendy is earning much more than Willie. Okay, so Willie must be doing something wrong. Okay? But that's not the case, right? Willie is making a rational choice. But it seems to be too low, only to our own eyes, because we don't see the whole thing. Okay? So what we are looking at in the data is that it's possible. It's one thing is that, okay, this data shows up because everyone is maximizing their lifetime income. So that everyone is making the rational choice. We just don't see it. Okay? Or it could be the other way. Okay, the people are making all sorts of mistakes. Okay, but whether it's a mistake or whether it's real rational choice, we never know at the end, right? Because to know whether it's a rational choice or it's a mistake, we need additional information that we actually cannot see. Okay, the additional information possibly comes from people living for multiple times, right? If they have multiple lives. Okay, then we may say that people are making mistakes or people are making rational choices. But with only one life, one point only in their lifetime data, we don't actually say. We cannot actually say that whether these individuals are making rational choices or just simply making mistakes. Okay? It's an interesting thing. So one thing that, there are things that we cannot know. So we have lots of guesses about the rate of return to education, but we actually don't know whether it's too high, whether it's too low. Okay. Questions? Okay. So this is a pretty interesting thing about this study of education and its rate of return. Okay. Oh, since I don't have much time, I will skip the exercise. But try this exercise 6-1, 6-3, 6-6. This is the pretty easy exercises. These are pretty easy exercise. If we knew the theory, then you should be able to answer it quite easily. Okay. Okay, now let's move on to the second model of education, which we call the signaling model. Okay. You probably studied about the signaling model actually in microeconomics class. If you have taken, let's say, I think microeconomics 2, information economics, signaling is a very big deal. And this signaling model of education is one of the very early models of signaling in microeconomics. Okay. So this, the model that I will show you today actually was published in 1973 by Michael Spencer, and then he got the Nobel Prize in economics for this article, mainly for this article, some years ago. Okay. So this is one of the early example of signaling model. You know this, what we mean by signal in general. The signals in information economics, individuals or agents have unobservable characteristics, which must be quite important to the other party, right? So let's say in this case, employer and employees are two parties in labor market. So employees have private information which employers cannot see. Okay? And so that there is, in certain cases, the employees have an incentive to send signal to show that what kind of abilities they have. So that's the starting point of signaling model. So this is very early model of signaling. So it's very easy to understand. So let's look at it now. Let's make a few assumptions. One, let's assume that education has no effect on individuals' productivity. So this is an opposite assumption of human capital investment model. Human capital model basically says that if you have more education, you accumulate knowledge and skills, then that are useful to your work, so you will become more productive. And that's why you are paid more. Okay? Now, the signaling model, this makes an extreme assumption. Okay, so this extreme assumption is made to clearly show how the signaling model works. So this is maybe unrealistic, but from model's point of view, if you make an extreme assumption, it's easy to understand how the model works. So in this model, let's assume that the education has no effect whatsoever on individual's ability, on individual's productivity. So by sitting here, right, you guys, you get nothing. Okay? You're just wasting your time. Okay? In terms of increasing your productivity. Okay? But there must be some value of education. So that's what the signaling model says later. Okay, then how the productivity is determined? Productivity is determined at birth. Cannot change it. You're just born with it. Okay? So, yeah, that makes some sense in a way. Okay? Okay, so for the signaling model, we should have asymmetric information. So this asymmetric information is this. Innate ability is known to each individual but cannot be observed by employers. So by just looking at you, the employer cannot know whether you have high ability or low ability. Okay, they will never know by just looking at you. Okay. There is a second assumption, also, which is quite important. So in this case, fourth assumption. Cost of schooling, cost of education differ by the individual's innate ability. Okay, here what we assume is that cost of schooling for high ability individuals is lower than that for low ability individuals. So if you have high ability, so you have born with higher productivity, you will find education much easier. Okay, then the person with lower ability or lower productivity. Why? I mean, it's probably the education teaches, in a way that to make that possible. So if you have low ability, for example, then you probably have to spend a lot more time in studying it, or you probably have to go to hire private tutors or somebody. So you have to actually pay extra, okay, in terms of time and money. So that seems to be a reasonable assumption. So this is actually very important assumption. So this makes the whole model possible. And it doesn't seem to be a bad assumption. It's obviously it's better assumption than saying the cost of schooling is low for low ability individuals and high for high ability individuals. Probably this is better or more realistic assumption to say that high ability, low cost, low ability, high cost. Okay. Now what we hear is that let's think of economy that has two kinds of individuals. One with high ability, the other with low ability. Okay, there are two groups. Okay. And to make things really simple, let's assume that high ability individuals, their marginal product of labor, so their productivity, let's say it's $2. So high ability is worth $2 to the employers. Low ability worth $1 to their employers. Okay? And let's assume that in this economy, 30% are of high ability, 70% of individuals are of low ability. Okay? So employers and the employees, the individuals know all this table. The only thing that employers don't know is whether an individual is at this line or this line. They know whole numbers, but they just not sure that whether you are from high ability group or whether you are from low ability group. Okay? If you ask anybody whether you are high ability or low ability, then people would say what? High ability. Why? Simply because they are treated as worth $2, so they will get $2. Okay? So why not? This guy never know whether I am high ability or low ability, so I should go for $2. Okay? Well, if this information was known to the individuals, then we don't have any problem. Just high ability gets $2, low ability gets $1, and that's it. Okay? But now we don't know. Okay, now let's think of a situation, one kind of equilibrium. This kind of equilibrium is called pooled equilibrium. Think of this situation. Let's say employer has no way of knowing who's high or who's low ability. Then what would the employer do? Employer would do is, okay, we don't know which one is which, so by law of large numbers, if I hire enough number of people, my labor force will be consisted of 30% of high ability, 70% of low ability. So we just pay the average. Okay? So at the end, the average cost will be the same as average return, because if we have, let's say, thousands of people working for me, then by law of large numbers, just 30 and 70% is likely. So that's the best way the employer would do, right? So just pay $1.30, just paying the average, weighted average, basically. Okay? So that makes sense. Now, the employer pays $1.30. Okay, from low ability point of view, that's very good, right? Because he gets 30 cents more than his actual worth. For high ability people, which is pretty bad, because they get 70 cents less. But there is no way of doing anything. If there is nothing to do, then we are stuck there. Okay? Okay. So all workers, so what happens? Let's say, think of a school. Now we have a school. Okay? But anyway, so employers don't care whether you go to school or not. They just pay you $1.30. Okay? Then as we said, the school does not make you more productive. Okay? It only costs you. An employer do not reward you for more schooling. So there is nobody will going to school, right? So everyone will just finish the minimum, and that's it. Even you are high ability, even if your cost is low, well, you have no incentive to pay even for low cost. Okay? Low ability obviously have no incentive, provided the high ability has no incentive ever. So everyone will have low education. Okay? Which means that from employer's point of view, everyone looks exactly the same. Okay? They have no education. Okay? We don't know whether they are high ability, low ability, just paying $1.30. So this is an equilibrium. Okay? You cannot break this equilibrium. Once you get here, there is no way of breaking it. Okay? But one thing is that high ability people will be very unhappy because being underpaid, right? And there is a problem here from employer's point of view is that since I don't know whether this person is high ability or low ability, when I assign these individual jobs, actually, I have to do it randomly. Okay? Let's say there are two kinds of jobs. There are more difficult, there are easier. So more difficult jobs, more delicate jobs, actually is more suitable for higher ability individuals who have higher productivity. And then easier jobs, more suitable for low ability individuals. Okay? But in this case, since we don't know who's high or who's low ability, we just randomly assign them. So in this case, the efficiency will be quite low because people are doing wrong kind of things. You are low ability, but you are doing very difficult things that it's above your qualification. Okay, so cannot do well. higher ability people doing only the menial things, simple things, okay, gets depressed, okay, underpaid and doing this stupid kind of thing, then, you probably that is not going to be. So, from economist point of view, we know that these people must be assigned to match their abilities. That's the most efficient way of organizing your workforce. So this is inefficient case. It's an equilibrium, inefficient, okay? And at least employers and high ability individuals don't want this. Low ability individuals obviously like this, but there are two groups of individuals, or one group of individuals and employers don't like this. So they want to make a change. How can we make a change? The way of making a change is to use actually the education. How do we use the education? Now, let's think of this case. We have the same table, but let's add this, cost of education. So high ability individuals, their education, cost of education is each year, let's say 1 year is $1, okay? But actually it's not just $1, it's half of a year, half of number of years. So for 10 years, for high ability individuals, let's say it's $5, the cost, okay? For low ability, it's whole Y. So 10 years for Y, for low ability individuals, it's $10, cost $10, okay? So there is cost difference. To make things simple, just I use very simple numbers. Actually, this is not my table. This is a 1973 original article table. Okay, he used this simple table to show how the signaling model works. It's amazing that you can write one of the most influential papers in economics using this simple table. Okay, you don't have any actual mathematics in here. The only mathematics he used is addition, subtraction, and division and multiplication. That's it. Okay? And using very simple table so you can understand it. Now, then how it works out. Okay, now employers use the education. How? Okay, the employer has declared this. Okay, I would say that if a job's applicant's education level is, let's say, some level Y star or higher, then I would treat her of high ability group. And if her education level is less than Y star, then I would say that she is of low ability group. Okay? So here the employer uses the observable information, the number of years of education, as the signal of the ability. Okay, so let's say I said, for example, like a certain number of years. You are above this, equal or above this, you are of high ability. Okay, so I will just pay you $2. Okay, if you are lower than this education level, I just think you are low ability. Okay, it doesn't matter whether your true ability is. Actually, I don't actually know. I just think that you are low ability, so I will pay you $1. Okay, that's how it works out. It's like if you have a college degree, I just think you are of high ability, so I will pay you $2. If you do not have college degree, I will just think you are of low ability, I will just pay you $1. Okay, so that's that's the situation we are saying. Now the question here is that if this is how the employers behave, whether we can have actual equilibrium. Now, if equilibrium exists, if this belief is sustainable, let's say this belief is totally wrong, then obviously this cannot be an equilibrium, right? The employer will find out that my belief was totally wrong, so they will have to change their belief or go back to pooled equilibrium. Like, I just pay you $1.30. Okay, I'm not gonna cause a headache to myself by thinking about this. Okay, so this equilibrium to be sustained, this belief must be confirmed. Then, okay, the employer will find, okay, this actually works. So the employer will just keep doing it. Now, how can this equilibrium actually exist? This equilibrium exists only this belief is the truth. Okay? Now, then let's think under what condition this belief is actual truth. Okay? So actual truth means that we have this certain level of Y star, then individuals who have education level of Y star or higher are actually high ability individuals. And lower than Y star is actually low ability individuals. Then the employers will be very happy, so we'll just keep doing it. Okay? Now, then how can it, what kind of conditions then we can think of? So the way of thinking about this, whether this separating equilibrium exists or not, is to ask whether this condition, okay, that this more than Y star equal or Y star is high ability or lower than Y star, low ability, this condition can actually exist, okay, in the economy. That's the question, whether the separating equilibrium exists only when this level of Y star actually exists. If, let's say, this level of Y star cannot exist, then we say the separating equilibrium cannot exist. Okay? So we are just thinking, we are just finding whether this kind of Y star can actually possible in this economy. Okay? Now, to do that, what we think is to make things really simple. This says Y star, if your Y is greater than Y star or equal, then you are high ability. Okay? So if you're less than Y star, low ability. Okay? Now from individual's point of view, what matters is whether you are treated being high or low ability. Okay? To be high ability, what you get is only, what you need is only Y star or higher. So what would be your choice of education level if you want to be high ability? Is it going to be Y star or more than Y star? It must be just Y star, right? So if your employer says, if you have a college degree, you have high ability education. You don't need master degree, okay? Because whether you have master or PhD or bachelor, you are treated the same. Just you get $2. Why do you pay extra for master or PhD? So what you would get is only the college degree, right? So in this case, the individual choose only Y star. So individual will choose to be treated high ability. This individual will choose only Y star. There is no need for more than Y star. Now, if you are somehow determined to be treated as low ability, what would you get? What education level would you get? Must be 0, right? If you're lower than college, you are low education. Okay? High school, middle school, primary school, no school, the same. What would you do? You would get no school, right? No point of going to school only to be treated the same. You just pay extra to get just $1. Okay? So actually, in this model, the thing is really simple. The individual will get only 0 or Y star. Okay? So what we need is just compare 0 and Y star case. That's it. Okay? That's what it says. Now, think of conditions for separating equilibrium. The conditions are, this must be true. This means that if anybody who gets Y star level of education, this must be high ability. This happens only when high ability chooses Y star, low ability chooses 0. Okay? If every high ability chooses Y star, if every low ability chooses 0, then this belief is true. Okay? Then under what conditions that happens? High ability will choose Y star only when the net benefit of choosing Y star exceeds the net benefit of choosing 0. Low ability will choose 0 only when net benefit of choosing 0 exceeds the net benefit of choosing Y star. Okay? Get it? It's just it's just a simple choice. You have either high ability or low ability. You have only two choices, 0 or Y star. You just get that benefit. Which one is greater? Okay? So the separating equilibrium exists only when high ability finds net benefit of y star is greater than the net benefit of 0. Low ability finds net benefit of 0 exceeds net benefit of y star. So high ability workers will choose y star years of education over 0 if net benefit of y star, 2 is the wage the person gets minus the cost of education, which is y star divided by 2. Must be here the let's say greater than or equal. Okay. If it's equal, let's say we assume the individual choose higher level. It's greater than or equal, then choosing 0 levels of education. 0 levels of education, you get $1, right? With no cost. So net benefit of choosing 0 education is just $1. Okay? Get it? Get this number? So your wage $1 minus cost of education, which is 0. So simple inequality. Okay, you can solve it. You don't need calculus. Just what's the case? This y star must be less than or equal to 2. Right? How about the low ability? Low ability will choose no education if net benefit of choosing 2 years, choosing y star years, which is 2 minus cost of education, which is y star, not divided by 2, right? Because it's low ability. 2 minus y star, and this must be less than 1. Okay? Then there is no incentive to choose y star level of education, which is y star is greater than 1. So can this region exist? Y star is greater than 1 and less than or equal to 2? Possible? Is it possible? It's possible, certainly. Okay, 1.5, for example, is in that region. So voila, we have separating equilibrium. If the employer sets their y star level between 1 and 2, then we will have separating equilibrium. Once they set it, if let's say, okay, if your education level is, let's say, 1.5 or higher, you are high ability. If your education level is less than 1.5, you are low ability. And these calculations show that if this is set, then every high ability will choose 1.5 years. Every low ability will choose 0 years. Okay? And there is no mistake in making this belief. So this is, everyone is happy. I mean, not everyone. Actually, low ability individual is worse off than pooled equilibrium. Now the low ability individual will get only $1, okay, instead of $1.30. So low ability individuals will be worse off compared to pooled equilibrium, but others will be very happy. High ability will be happy because they will get $2 instead of 1.3, and employers will be happy because now they know who's high and who's low ability, so they can make much more efficient production decisions. Okay, get it? And we know that now that this signaling actually works. Okay. So if y star 1 and 2, workers sort themselves by ability and employers' belief is confirmed. Right? And we call that separating equilibrium. Okay, this is just an example. So if it's y star, this is a way of showing it using graph. Yeah, this is graph from the original article, actually. So what you need to see is that this is the wage level. If up to 1.5, $1. More than 1.5 or higher, $2. Okay, so this is the benefit of education. This is cost of it. This is cost line. Okay, and individuals will choose the point where the net benefit is the highest. So for low ability, which is CL, the net benefit is highest, obviously A0 point, right? So the distance between net benefit and cost. And high ability, obviously, this is the biggest. So you can use the diagram like this to see the how the signaling model works, or you can use this inequality. If it's 3 years, which is actually too much, okay, then you can see that low ability, this is the best choice. How about high ability? For high ability, what is the best choice? It's 0 years. Okay, if this is shorter, okay, this is less than $1. This is $1. So high ability will choose 0 years. If it's too high, high ability find it's just too costly to get to 3 years. Okay, so if this is the case, actually we go back to separating, not pooled equilibrium, because no one will get education. So everyone will now look the same. So we go back to pooled equilibrium. But what it shows here is that we have a room for separating equilibrium. Okay. So in the separating equilibrium, what's actually interesting here is that even if the education does not augment, does not increase workers' productivity, we still see the positive relationship between education and wage, right? No education gets $1. 1.5 years of education gets $2. Okay? If we make things more complicated, we can have, let's say, different levels of abilities. Then you can see that, generally we should have positively more education, and we can have, higher wages. Okay? For example, like we can think of 3 groups, like low, middle, high education group, high ability group. Then obviously, high ability group requires higher education than middle group, and middle group requires higher education than low group. We can have 3 cases, then we can still figure out the separate equilibrium case. Then in general, what we see is that it must be that more education people will get higher salaries, higher wages. Not because education makes them more productive, but because education helps the firms to distinguish high ability from low ability. So it's just a signal, not actual, increase of productivity. It's just a signal. Okay, so signal improves the quality of task worker matching in the society. That's what I said. So if we compare this separate signaling model to the human capital investment model, is that it seems that they actually can explain the same thing. Why more educated people earn more? Human capital investment model says that more educated people have more human capital, more productive. That's why they earn more. Signaling model says more educated people do not necessarily have more human capital. Basically, there is no human capital like this. Okay? They are more paid because their education can work as a signal for their inborn abilities. Okay? So the role of education is very different from in these 2 models. Okay? In the human capital investment model, education has, in a way, there is a real value to education, like a substantial value. You educated them, then they become more productive. In the signaling model, you educated them. No. Okay. It doesn't help these individuals to be more productive. Okay. Actually, from signaling model's point of view, to society better off, we actually need to get people to get only the minimum level of education as a signal. Okay. So if you need only, let's say, high school degree to signal yourself as a high ability individual, going to college is just a waste of money and resources. Okay? So if you believe in signaling model, then you have to find this minimum level of education that people can be distinguished. If you're a believer in human capital investment model, okay, in a way, more education probably it's a way to go. Okay? So it depends on how you believe. Actually, the role of education is very different. Okay. So obviously, there has been debates whether the signaling model is correct or human capital investment model is correct. For example, in the society, we see more educated people get higher income. Is it because that education is a signal, or is it because they learn and accumulate human capital in schools? Okay, so there has been a debate, and nowadays we don't have much debate because at the end it's unknowable. Okay, it's not knowable basically. Okay? If you think about how do you know? Okay. So at the end it's probably both. Okay, we just reach up. No, it's probably both, but we are not sure whether the human capital is significantly increased by education or whether it's a signal. So if you actually read some articles in, let's say, in popular publication like in newspapers or in magazines, then actually you will see that in some articles, magazines, you will see that some columns that thinking that education is a signal, some columns thinking that education is a human capital investment. So depending on how they look at it, their ideas are quite different. It's very interesting to see. But academically, it has been shown that it's very difficult. It's almost impossible to know that it's a purely signal or purely human capital. It's probably both. Okay. Okay, with this comment, I will finish this class.